Hey everyone, how's it going? So this video isn't actually going to be focusing on a new topic, but instead it's going to be correcting a mistake that I made in my last video. So my last video we learned about allosteric and orthosteric sites and allosteric modulators, and unfortunately I made a mistake in my explanation. I'm really sorry if you were confused or misled by my last video. This wasn't my intention at all, and I'm sorry. I should have been more careful and I should have reviewed my content more thoroughly when making my last video. So in this quick video, we're going to correct that mistake. Let's go. So in the last video, we learned all about orthosteric sites and allosteric sites, but I made the mistake of showing that orthosteric sites and allosteric sites are two distinct receptors on the same cell, and this is not true. This isn't the case. What is the truth is that orthosteric sites and allosteric sites are two different sites as part of the same receptor. So it's not two different receptors on the same cell. You have one cell with one receptor, and this receptor has different sites, an orthosteric site and allosteric sites. So this diagram would be a more accurate representation because, as you can see, you have one receptor with a main orthosteric site and then a secondary allosteric site. But all the other qualities we mentioned about in allosteric modulation in the last video still applies. So agonists can bind to orthosteric sites in order to produce responses inside your cell, and modulators can bind to your allosteric sites to regulate or modulate these responses, maybe to make them stronger or to make them weaker. So because your orthosteric site and your allosteric sites are separate sites of the same receptor, this means that when a modulator comes and binds to your allosteric site, it still permits for agonists to come and bind to your orthosteric site because these are two distinct sites on the same receptors. It's not like your agonists and your modulators are both competing to bind onto the same site, they're binding onto different sites. So when your modulators come and bind onto your allosteric site, this can modulate or regulate the responses produced by agonists binding onto orthosteric sites. And this is because when your modulator comes and binds to your allosteric site, it can change the conformation or the shape of your receptor. This is something we discussed in the last episode. So the conformation of your receptor protein is changed, and this can increase or decrease the receptiveness of your receptor or the affinity of your receptor to your agonist. So when your allosteric modulator comes and binds onto your receptor and it initiates a change in conformation, then this can have many different effects on the responses produced by your agonist. It can enhance or potentiate, or it can weaken/antagonize your responses. So an example of enhancing or potentiating responses could be an increase in efficacy or potency. An example of weakening or antagonizing responses could be a decrease or in efficacy or potency. Now, it's also possible for multiple agonists to bind onto the same orthosteric sites of a receptor, and these multiple agonists may activate different transduction pathways that can lead to different responses. So for example, your first agonist A might produce this first transduction pathway leading to this response, while your second agonist B might produce this transduction pathway leading to this different response. Now, your allosteric modulator, it might change your receptor's conformation, and this new conformation of your orthosteric site might be better suited to one agonist over the other agonist. So this may result in your modulator selectively potentiating or enhancing one of your responses, but not the other. So maybe your agonist A's response can get potentiated, so higher potency, higher efficacy, stronger response, while the response of agonist B doesn't get the same benefit. Or maybe when the modulator binds to the allosteric site and it changes the conformation of your receptor, it changes the conformation of your orthosteric site. Your orthosteric site might now have higher attraction or affinity to one of your agonists over the other. So there's a whole new layer of complexity that arises when you start looking at allosteric modulation. So hopefully this should help clear up my mistakes from my past video. All the other characteristics that we learned about allosteric modulation, they're all the same. It's just that allosteric and orthosteric sites are not two separate receptors. Instead, they are part of the same receptor, just two distinct sites on that same receptor, rather than two different receptors on the same cell. And that's why they're called orthosteric and allosteric sites, not orthosteric and allosteric receptors. I should have known that. That's my bad. I apologize again if I confused you. That's my bad. Hopefully this video can help clear things up. Thank you so much for your understanding and for taking the time to watch this video. I hope you enjoyed, and join us next time where we're going to learn about all different types of antagonists. Take care for now.